Okay, let's jump straight into this explainer. Today, we're basically going to equip you with a superpower, a sort of X-ray vision. We're going to peer right through the ceiling tiles and the drywall of your building to uncover the hidden mechanical solutions working behind the scenes. These are the unsung heroes keeping our shared public spaces quiet and comfortable. You know, the science of HVAC noise control is something we literally never think about until it fails. But I promise you, once you see how all this works, you're never going to look at an office building the same way again. Seriously, picture this. You're sitting at your desk, you're really trying to lock it in focus, and suddenly, you hear your coworker next door as if they're sitting right inside your ceiling vent. You can hear every single word of their phone call or maybe the annoying buzzing of their equipment. It's incredibly distracting, right? Well, that annoyance is completely valid. It's actually a super common office nuisance. So today, we're going to look behind the walls, figure out exactly why that happens, and more importantly, how the pros actually fix it. To do that, here is our building directory for today's journey. We'll start at your desk with Section 1, the invisible office nuisance. Then we look up for Section 2, silencing the ceiling plenum. After that, we'll head down the hall for Section 3, muffling rooms and ducts. And finally, we'll climb all the way up to the roof for Section 4, blanketing exterior equipment noise. Let's kick things off with Section 1, the invisible office nuisance, sound in public spaces. Now look, a little white noise, sure, some people actually like that to help them sleep or focus. But when we're dealing with shared public spaces, think offices, hospitals, schools, conference rooms, a high level of silence is absolutely crucial. So if you're stuck in a big office building and you are clearly hearing the person in the room next to you, that noise is likely traveling along multiple paths to get to your ears. First off, it could just be that the walls between you are uninsulated and sound is radiating straight through the drywall. But the biggest culprit? It's often right above you, the unducted return air grill. That noise travels up through their ceiling grill, bounces all around the shared space up there, and drops right back down through yours. Moving right along to Section 2, silencing the ceiling plenum, fixing the grill. So if the noise is raining down from the ceiling, that's exactly where contractors need to focus. But before we look at the fixes, let's unpack a little industry jargon real quick so we all understand the exact space we're X-raying. The return air plenum. This is simply the shared, open space above the drop ceiling where the air from your office naturally flows back to the air handler. If your building has an unducted return system, the air, and therefore the sound, freely mixes in this giant open cavern above all the offices. So how do HVAC pros stop noise from sneaking in or out of the return air grill in this giant open space? Well, you've generally got three standard solutions. The first is the return air boot. It's essentially an elbow made of fiberglass ductboard. It definitely works, but it needs a solid attachment to the structure. It can't just rest on the grill, which makes it a bit slow to install. Option 2 is grabbing a length of flexible duct and attaching it to the grill, leaving the other end open to the plenum. This also needs structural support so it doesn't just collapse on itself. But the third solution? That's the canopy. Made from fiberglass or foam, this thing is incredibly lightweight. It just sits directly on top of the return air grill without any extra support at all. It completely blocks the line of sight into the ceiling, comes in standard sizes, and because it installs so quickly, it's pretty much always the fastest and cheapest option. It's a real game changer. But here's where it gets kind of funny, and it brilliantly illustrates what happens when building designs get a little complicated. Sometimes offices have full-height walls that go way past the drop ceiling, all the way up to the actual roof deck. That completely blocks the return air path. So to fix the airflow, contractors will often cut an opening in that wall above the ceiling. But by doing that, they accidentally create a perfect little tunnel for noise to travel freely from one side of the wall to the other. In the industry, they call this issue crosstalk. To fix this crosstalk problem, you obviously can't just leave a gaping hole in the wall. The workaround is using a specially lined section of ductwork configured with two elbows. You're essentially creating a Z or a U shape right through the wall. Whether these are pre-built or whipped up in a contractor's sheet metal shop, they use fiberglass board or other sound-absorbing materials on the inside. The air can easily wind its way through those elbows, but the sound waves? They crash into those sound-absorbing walls and get drastically dampened before they ever reach the next room. All right, let's head down the hall for Section 3, muffling rooms and ducts, the main defense. We're moving away from the individual office space now and heading over to the mechanical rooms and the main ductwork. This is our main line of defense against heavy machinery noise. When you're dealing with massive rooftop package units, the noise doesn't just seep through walls. It plunges straight down into the floors below, right through the metal ductwork. The go-to, relatively low-cost method for choking off that sound is the duct silencer. These things are incredibly versatile. You can get them in round or rectangular sizes, and they are completely scalable, meaning you can build them to handle massive systems just by stacking more modules together. Typically, they'll slap a duct silencer on the main supply duct right near the rooftop AC, and often another one on the return air main duct. It literally chokes off the noise before it can travel through the building's metallic veins. Now, if you happen to be in an older building, the root of the problem might actually be the fundamental technology itself. So how do modern energy retrofit projects handle this? Well, the old way relied on these massive utility fans, or vane axial fans, paired with highly restrictive sound traps. The problem is those required really high static pressure just to force the air through, which meant the system had to work harder and, you guessed it, louder. The new, much smarter practice is to completely rip out those old fans and sound traps and drop in a modern fan wall system. These fan walls are unbelievably quiet by design and run so much more efficiently without needing those old high-pressure sound traps at all. Okay, quick timeout before we look at mechanical rooms. I really want to remind you of the core philosophy of this whole explainer. Effective noise control isn't just mindlessly throwing insulation at a wall and hoping for the best. You have to identify two critical things: exactly what the source of the noise is, and the specific physical path it takes to reach the people inside. Whether it's radiating straight through drywall or traveling down an AC duct, knowing that path dictates the exact weapon you need to pull from your sound dampening toolkit. And speaking of that toolkit, let's look at the three-part defense they use to lock down a super noisy air handler sitting in a mechanical room right next to an occupied office. First up, if noise is riding the ducts, you drop in a special version of a duct silencer shaped like a 90-degree elbow. Second, if the noise is just blasting straight through the drywall, you deaden it by installing acoustical wall panels. These bad boys range from 2 to 4 inches thick, featuring a layer of fiberglass sandwiched between a solid metal outer wall and a perforated metal inner wall for maximum absorption. And third, if that mechanical room happens to be near a sensitive outdoor space, noise might actually bleed outside. To shut that down, you use special acoustical fresh air louvers to dampen any sound trying to escape the building. Finally, we've made it to the top. Section 4, Blanketing Exterior Equipment Noise. The rooftop. Let's climb all the way up to the roof to deal with the source of some of the absolute most stubborn vibrations and mechanical sounds in the entire HVAC world. Now, even though engineers design modern rooftop equipment to be as quiet as mathematically possible, outdoor machinery, like refrigerant compressors, big packaged units, and air-cooled chillers, still generate residual noise. There's just no way around it. And frankly, those low-frequency hums and mechanical vibrations can be incredibly bothersome to folks trying to work on the upper floors. To tackle this right at the source, contractors bring out the heavy artillery, acoustic blankets. What's really impressive about these is that they aren't one-size-fits-all. They are custom-made to perfectly hug the specific contours of the equipment. They wrap right around that noisy compressor. And these aren't your standard blankets. They're heavy-duty, engineered to shrug off harsh outdoor elements and survive the extreme working temperatures of a refrigerant system. Best of all, they're designed so a mechanic can easily open or remove them for routine maintenance without completely destroying the soundproofing. Well, we've covered a ton of ground today, all the way from the ceiling right above your desk up to the massive chillers on the roof. So I want to leave you with a question to test out your brand new X-ray vision. Based on everything you've learned in this explainer today, what do you think is the loudest HVAC noise in your current building? Is it crosstalk from the office next door, a vibrating main duct? And more importantly, now that you actually know the hidden science of silence, which of these solutions do you need to finally fix it? Next time you walk into the office, just keep your ears open. You will be absolutely amazed at what you can hear, and now what you can figure out how to silence.